Hello everyone. So this is the fourth lecture of matrices, and in this lecture we are going to discuss some of the good problems of matrices. Okay. In our previous lecture we discussed about Calamantine theorem and matrix method to solve system of linear equation. And I thought one topic I must tell you before I start problem solving. So that topic, just of 3-4 minutes, I'll be taking in this lecture. So that topic is trace. So first of all, you have to consider a diagonal matrix like this. Right, as we know that in diagonal matrix the elements which are in the you can say the elements which are in the position, or you can say the elements where is row number is not equals to column number, those elements are equal to 0, and rest of the three where I is equals to j, they are the main elements of diagonal matrix. So these elements are called elements of principal diagonal. This is a principal diagonal. Okay, whatever be the spelling. And talking about trace, then it is sigma aii for the diagonal matrix. So we can write it as a11 plus a22 plus a33. Okay. So this is actually the trace of matrix. Now talking about some of the properties of trace. So we just write it in this way: trace, like trace of A. Okay. Suppose A matrix is like this: 1 2 3 0 0 0 0 0 0, like this, right? So what will be the value of trace? That will be 1 plus 2 plus 3, that will be 6, right? Now talking about properties of trace of matrix. So trace of lambda of A, where lambda is any scalar value, just you have to use the property which you used in determinants, that lambda power m, and that will be out of this trace, and like this we can write it. Okay. So quite simple it is, and you have to understand, because some problems, you can say 5% problems, are also been asked from this topic trace. Okay, so this was the topic which I supposed to do this in this lecture, and now we are going to discuss the some of the good problems of matrices, which I selected. 5 problems are there as per the our previous trends. 5 problems we take, that is the quality questions, and we will solve it one by one. Okay. So let me start with one easy problem. Okay, comparatively. So we have been given with the matrix A of 3 cross 3 order, and the determinant of A is given as 5, and a quantity we have to calculate, that is determinant of 2 adjoint into 3A adjoint of 2A, like this, which I'm writing in. You see this, and don't see what I'm speaking, see what I'm writing. Because in mathematics we have to see the symbols also, we have to see the brackets also. So in that way. So it is given as 2 power alpha, 3 power beta, 5 power gamma, and we have to find the value of alpha plus beta plus gamma, right? So this is the question, and now we have to solve this. Okay, so I am turning the slide and we'll solve it there. Okay, so the required determinant is like this, right? So the way of solving these type of question is a very, you can say, sophisticated way. First of all, you have to see this adjoint. Okay, you have to see this adjoint. As we, as it in question given that A is a matrix of order 3. So this whole value 3A into adjoint of 2A, this will be a 3 cross 3 matrix. And when you take its adjoint, that will also be a 3 cross 3 matrix. So we have to just use the property of determinant, that this is a 3 cross 3 and 2 is a scalar quantity, so it will come as 2 power 3, and then adjoint of 3A adjoint of 2A, right? Now as we know, adjoint of any you can say this quantity, let's say it is an x quantity. So if we have to find the determinant of adjoint of x, then that will be simply uh, determinant of x raised to the power n minus 1, where n is the order, where here the n is equals to 3. So we will write it in this way. See, 3a adjoint of 2a, and here we will write whole square. Right. Now, talking about let me first take it to next slide, right? Okay, so let me take it to next slide and then we will discuss it. So it is coming as 2 power 3, 3a adjoint of 2a square, right? So again we have to proceed like this. Just you can split these squares into two brackets and you will get like this, right? And again it will repeat. Just I'm doing it so that you will not feel confused. Now 3. Now this a into adjoint of 2a. It will be a matrix of order 3. We will just take 3 power 3, and from there also 3 power 3. So it will be 3 power 3 whole square. Right. Now determinant of a. We have to take determinant of a whole square. Adjoint of 2a. And here also adjoint of 2a determinant with determinant. So adjoint of 2a, determinant of adjoint of 2a whole square. So what we'll take 2a, just see, first you have to see this like this. Take a deep breath and just confirm me whether it is correct or not. I hope it is correct. Here it will be determinant of 2a whole square, and here also whole square, so that will be whole power 4. Now, one more step before we proceed to the final solution. Determinant of a is given as 5, 5 is square. Now since it is a 3 cross 3, so 2 power 4 and power 3, so 2 power 12, right? And 5 power 4. So as we just add on the powers, we will get it as 2 power 15, 3 power 6 and 5 power 6. I hope we are going in the correct path, and as it is matching our answer, alpha, beta, gamma. So alpha is coming as 15, beta is coming as 6, gamma is coming as 6. Just add these values, you will see the alpha plus beta plus gamma is 27, right? Questions of matrices are little more lengthy, but if you go it very calmly and with the composure, then you can ace it also. Okay, little questions are little lengthy, and I have taken the questions which are at good length. Like this question was easy. It was a pretty easy question. You can say it was a beginner's question of matrices. Talking about at a decent level, at the level which we have studied, it is a pretty easy question. But actually, you have to be very careful on using the properties, because if you just use it randomly, answer will not come and your process will automatically be quite different from what actually it is. Okay. So, talking about second question, first question we discussed so far, and let's start the second question. Question number 2. So, question number 2. So, let's take another question from our 5 question slot. Take this question. A is a 3 cross 3 matrix, real matrix. There are two matrices, real and complex. Where we have iota, we say it a complex matrix. But it is not in our more specifically at the level. It's at higher mathematics level we have a complex matrix. Okay, so we will discuss real matrix. So it is a 3 cross 3 real matrix, and in such a way that a square into this, just you see the what I'm writing, I'll not pronounce, otherwise it will mean different. Okay, so just see this, minus 4 a minus I. This is a null matrix. Okay, O is representing null matrix, I is representing identity matrix. Now we are given with a power 5 is expressed as alpha a square plus beta a plus gamma I. Now we have to again find alpha plus beta plus gamma. So these questions, first of all, I discussed with you Calle-Milton theorem. It is not from that actually. Calle-Milton theorem is very less asked, or it is asked in the higher mathematics level. But talking about this question, so you have to make some manipulations here. which I suppose that I have not discussed in your sessions. So through this question, I'll make sure that you will understand that also. So just see a square into a minus 2i minus 4 into a minus I. Just multiplying it, you will get like this: a square I minus 4a plus 4i. Now a square into identity matrix, that will be a square only, hopefully, right? Yeah. So a cube, just taking these values to the RHS, 2a square plus 4a minus 4i. Okay. Now this is a cube. We have to find a5 as per the question. How we can do this? Very easily. Just see. Pre-multiplying this particular equation which we got, matrix equation, not actually matrix equation, but it is an equation which is involving matrix. So I said matrix equation. That matrix equation is different. This is different. So we have to just pre-multiply by a, and you will get a4 2a cube 4a square minus 4a ai again a. Now just put a cube, the value of a cube from this particular equation. You will get it 4a square plus 8a. 8a minus 4a, 4a. Okay, wait. I think we are okay. Done. So 4a square 8 and minus 8i. Wait, 4 4 8. Yeah. Here we will take 4a square, and here already 4a square is present, so 8a square plus 4a minus 8i. Just first of all check this whether it is correct or not. Okay, I hope so it is correct, but we have to check first of all. A4, because mathematics is full of calculations. If we miss any calculation, whole process will go out. Minus 8. Okay, 8a square plus 4a minus 8i. 8a square plus 4a minus 8i. Okay, now again pre-multiplying by a, 8a cube plus 4a square, yeah, minus 8a. Now again putting a cube, what will be 2a plus 4a plus 4i. 2a plus, okay, 2a square, okay, 2a square plus 4a plus 4i. See, I can't just change, go to previous slide, okay, due to some restriction, I don't know. So I just see the question there side by, and I just write. Okay, so any confusion if you have, you can let me know. 16 and 4 20. 32 minus 8 24. 32. Some calculation we are just missing here, right? Because plus minus mistake is there. Okay, here it is minus 4i. I wrote it differently, so it is not coming as per the requirement. Minus 4i, you just check a cube, you will get 2a square plus 4a minus 4i, right? Yeah. Now comparing to the whatever is given to us, alpha, beta, gamma. Alpha is coming as 20, beta is coming as 24, and gamma is coming as minus 32. Just adding all those, alpha plus beta plus gamma is 12. As simple as that. Okay, so done. This question is also done. This is the second question, and we have already taken 14 minutes of the session. So questions I said are lengthy, so it will take some time. So I have not rated difficulty, as you see. First questions are lengthy, and questions are quite, you can say, conceptual. So we will rate it, and at last we'll rate that which question is supposed to be at what level. Okay, because first we have to solve. Okay, so question number 3. So our question number 3 will be this question. Okay, Question number 3. Here the arrangement is different. I have arranged the question in different way. In the way I found, I just arranged it. But here when I'm discussing with you, I'm just seeing the level of the question and I'm discussing it in increasing order. First we are discussing a comparatively easier problem, and then we are just shifting towards the you can say little more difficult problems. Okay, so here also it is given by A is a matrix of order 3 cross 3 such that determinant of A is given as -4, -4, right, -4. So like this, A plus I is given to us 1A1, 1A1, 210, A12. Okay, so A will be coming as identity matrix, as simple as that. 1 1 1 0 0 0 0 0, like this. This you have to subtract. I am just writing the value which we will get after subtracting. Okay, 0 1. So, simple, you can do directly also, no issues. Now I think we are going the correct path. Let me check it out. A, we are writing it 0A1. Okay, 200 A11. Got it? I hope you got it. Okay. Now finding the determinant, expanding along second row, because we will prefer where more zeros are present. That term will get totally, you can say, dismissed. So talking about that, -2, expanding along row 2. Okay, expanding along row 2. So -2 and A -1. This is coming out to be -4 as per the question, I think, right? So A is coming at 3. Now A plus 1 into adjoint of A -1 into A, like this. So 4 adjoint of 2A, like this. And adjoint is a 3 cross 3. Okay, so 4 cube and adjoint of 2A. Just I'm making it completed here only. Adjoint of 2A is determinant of 2A, power 2, 6. I think you are getting what I'm writing. So we are on the same page, I think. Then fine. Otherwise, issues are there. So the question is giving you that this determinant is of 2m and 3n. So first, when you will solve it in first instant, you will see that we are having no 3n wala term. So it means we are going in the wrong way. But no, we are going the correct way. And actually, in this question, we will be having no term of that value. Okay. So let me search it out. 4 cube adjoint of 2a square, 2a square and 2 3 6, 2 power 6, 2 power 12, 2 power 4. Just adding them, 16, 2 power 16. So as it is coming 2 power 16, 3 power 0, just compare m. M is coming as 16. Just you solve by yourself. Okay, I have less slide here. I will have to add, so I'm just making it complete here only. So m plus n is given you as 16, and this is our correct answer. And here we go. Okay, so done, 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 done. And next question we are going to discuss. This was the problem number 3. Now going towards problem number 4 and understanding it well. Question number 4. This is your. Let me first handle that the way we have done. I have to numbering it out. Yes, A is a 3 cross 3 matrix, real matrix, and in this way it is given. See, as I said, adjoint is very important. Properties of adjoint are very, very important. Once you master that through problem solving, you can say 80%, 70% of the matrix is done. In terms of execution, theory we have done already. Execution is completed uh, up to 80%. It will complete to up to 80% when you solve the problems of adjoint, because it's a very important topic. Now this is given first of all, so it is in parts. Okay, so we will go step by step. First you have to solve this. Okay, so just see the chunk and adjoint of a, determinant of a power. This was the formula which I discussed with you, that you have to remember it as a trick, right? That how you have to proceed. Just see in second lecture we have discussed determinant of a power. Since it's 3 cross 3 to 2 power, you have to count adjoint. 3 adjoint, so power 3. This is 81. It is 2 power 3, 8. So it is root 3 power 8. If you will just simplify, you will get this. Okay, hopefully you are getting the same. So determinant of a is root 3. Okay, now talking about next segment of this problem. First we'll write this and now we will proceed. It has been given in a sample space, or you can say a set, and belonging to integer, adjoint of. You'll find these problems on internet also, because these are taken from internet only. These are not my, because in mathematics to self curate we have to see many values, so I just take from internet only. So you can check there out also. But the questions are quite same, only I have checked it, then I have taken. Okay. Now you have to find something else, but first you have to find the value of n. It was a lengthy problem. All problems are which you have taken is lengthy only. So just take it the way. Determinant of a power 2 and then 4. Are you getting that? The property we are using of adjoint of adjoint of a, that is determinant of a raised to the power n minus 1, and here 2, so it's whole square, that is 2 square, that is 4. And now just multiplying it with this particular value. Okay, in this way. Got it? Now just comparing the powers. N square plus 1 minus 2n, 3n square minus 5n minus 4, 2n square minus 3n minus 5, 2n square minus 3n minus 5. Are you getting? We are going in this way, that n belongs to integer. You will know the importance. Many times, which I have seen so far, we ignore the conditions, we ignore the whatever the question says, that n belongs to integer, n belongs to. You will know the importance here. In these type of problem you will understand, and this will make you out of the race also. You will take n is equals to 5 by 2 because you have not read that it should be only fraction, it should be only integer. You have taken fractional value, your answer will not come. Okay, so you have to take care of that also. Every condition in mathematics is implying something. Okay, and solving a question doesn't mean that you solve it. No, you have to understand the conditions, and your answer and conditions should match. If it is not matching, it means you are missing something, and you have to find that. And once you find that, you will see the beauty of mathematics. Okay. Questions are quietly, you can see, very minutely created in these technical subjects like physics, mathematics. They have created a question very technically. Actually, in mathematics, very much technicality is there. And should belongs to integer and should be equals to minus 1. Right? Why it is coming differently? We are missing something here. Wait. We are missing something here. Wait, 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 2 and minus 5. Okay. Determinant of A is root 3. Okay. And n should belong to sample space. Why not we are getting the answer? Uh, Square 2 into 2 4, and minus 1 square, n square plus 1 minus 2n, 2n square minus 3n, or minus 4 minus 5. Equation is correct. 2n square minus 5n is also correct. and n into 2 and minus 1 plus 1 and is equals to minus 1, and it should not be 5 by 2. Now it is said that we have to find n belongs to sample space like this. It is coming 0. How it is possible? We have to check it out. So let me check it. So there was a missing question. We have written wrong question. I have checked it out and I'll not edit this part. This was the question mistake. We'll cover it. This is wrong. This is also wrong. Covering it with the uh, what we have given in question, that 2 square. That is not 2 square. That is just 2. So just correcting it. Adjoint of A. If someone else will be in my place, they may say to you that they may edit the part of those, but I'm not like that. It was a question misprint or whatever from wherever I just received this question. There was a misprint. Okay, now this type of question is there, and we have to proceed like this: 2 into n minus 1 whole square. Okay, property we have already used. 4. It will be 4 by 2, and it came 2. Now just compare. Minus 4 and n square minus n and minus 6. Okay, now we are on the correct path like this. And is 3 and n is minus 2. And that was also a lesson for us, that in last question I have make you clear with the what you say conditions of mathematics integer wala hai na? And here it is 3 and minus 2, so we'll take both value, both are integers. So sigma n belongs to the sample space, and this like this. 3 square is 9. 9 plus 3, how much? 12. Okay, and square, this will be 3. This will be root 3 power 12, that will be 3 power 6, 27, 729, that is 732. Clear? Done? All set? This question was fourth question. Now talking about the last question of the session, and it will make you learn anything about matrices. A very important question I am taking in the last section. All questions are very, very of good quality and very good, you can say, center varieties. But this fifth variety is quite confusing to some of the people also. So I'm discussing with you this. A is equals to 1 by root 2 minus 201. P is cos theta minus sine theta cos theta. A B matrix is given to you, that is in PAPT form, and we have to find a, and also it is given with the C matrix, that is P transpose B power 10 and P, and this C, the sum of diagonal elements of this elements of C is m by n. We have to find m plus n, and also we have to understand greatest common divisor of m and n should be 1. Okay, so how to proceed this? First C, you have to understand, just calculate P into P transpose. P into P transpose, I'm calculating with you also, because I have to make you understand, because from next time you have to use this result. Most of the time it will be forming the same, but in the first instant I'll make you calculate and make you assure with the mathematics. Cos theta minus sine theta cos theta sine theta, transpose we are taking, that's minus sine theta cos theta. Just take cos square theta plus sine square theta, 1. It is 0, 0, 1. This is the identity. Done. So matrix B is your PAP transpose. Now see, you have to write this in this way: P A P transpose है ना, power 10, ठीक है. So then we have P. When you just expand it, the way P A P transpose P A P transpose like this up to P. You will see P into P transpose will always make identity, always, and you will be left with only A power 10. Okay, so C matrix is nothing but A power 10. Now how to find this A power 10? So just C A is like this, 1 by root 2. You will see pattern after just calculating 1 2. That is A square first you calculate. It will be like this. See 1 by 2, it is like this square, and here it is going like minus 2 by root 2 and minus 2 0 1. Okay, just let me know whether I'm correct or not. I think I'm correct. So square is coming as 1 by 2. We have taken the correct values. Bangalore is correctly taken. So 1 by 2. Okay, minus root 2 minus 2 0 and 1. Okay, done. So a square is coming as 1 by 2 minus root 2 minus 2 like this. Wait, yeah, minus root 2 and this is coming 0, this is coming 1. Okay, calculating a power 4 now. You have to calculate up to a power 10. Just calculate in this way only. 1 by 2 minus 2 minus root 2 minus 2 0 1. 1 by 2 minus root 2 minus 2 0 1. Because pattern is not clearly visible here, or it might be visible and not visible to me right now. And we have to take some slides, so give me 2 minutes. Just I'm taking the slides, adding the slides. So yeah. So in this question, as we saw that we have to find the diagonal element sum, not all the element sum. We have to just see the pattern in diagonal elements. So square is coming as 1 by root 2 whole square, and then here something something. Diagonal element means principal diagonal. We have discussed principal diagonal. We have to consider that. That's coming 0 1, and here something is going and minus root 2 minus 2. That doesn't matter. A cube. When you will calculate a cube, will be in this way: 1 something something here, that is minus root 2 minus 2, and 1 by root 2 0 1 minus root minus 2. Just see here, it is 1 by 2 root 2, and here it is becoming 0. This property, this part is becoming 0, and there is something coming, and here it is also 0, and here it is also 1. So what we have observed, that as we are proceeding with AQ, you can say A cube and all. So as we are proceeding with A cube and all, so we are just seeing that diagonal elements are behaving in this way. Like in A cube, it is like this: 1 and 0, and here something 1. You have to consider this. So in A10, we can predict that it will be like this: 1 by root 2 of the power 10 plus 1. That will be 32, and 1 by 2 32 1, 33 by 32. This will be coming, adding this, because it is greatest common factor is 1 only. M by n, m is 32, m is 33, n is 32, m plus n is 65. That's it. Because diagonal element, this is a principal diagonal. See, this is a principal diagonal, है ना? principal diagonal A. So it is a principal diagonal, so you have to just add the elements of principal diagonal, because you have to find the sum of the diagonal elements of C. Okay, C matrix का diagonal element निकालना था, तो 1 का pattern same चल रहा है, as you can see 1 is going same in A cube, A4 and all, but just this is changing as per this power. So at 810 this will behave like this. Okay, so you have to not be in trap of this element. Okay, this will become weird, but in according to question we have to find just the sum of the diagonal elements. So diagonal is the principal diagonal. Diagonal always means principal diagonal. Principal diagonal means this diagonal. Okay, this was our discussion of questions, and with this we have completed matrices chapter, and I'll rate the difficulty level of question. First question which we have taken, difficulty will be 7 on 10. Question number 2, difficulty will be 7 on 10. Question 3, difficulty will be wait, 7.5 on 10. Question number 4, difficulty will be 7.5. All are in the range of 7 only. And question number 5 which we have taken, 8 on 10. Overall 7.5 the difficulty is there. Good quality questions we have taken. Okay, so yes, with this we are just ending the session, and it is already 36 minutes. Okay, the one of the most lengthy sessions of maybe in our whole session, physics, chemistry, math, or in mathematics, it is one of the lengthy session. So thank you for joining me in this session. Next session we will be starting the new chapter, that is vector. Okay, as I already announced, and the lecture sequence will be shared with you very soon. And this lecture you will be getting on 28th. Yeah, hopefully on 28th you will be getting this lecture of mathematics. Let me see the available slots, and I'll make you clearly with the timings of our session. Okay, so as I can see, 28th 10 a.m. morning you will get this session. Vector we will start in already upcoming week, from more or less 29th, maybe, or 30th surely. Yeah? 30th surely, 29th maybe, because this session will come on 28th. So I'll plan that whether I should start with 29th or 30th of April vectors. Okay, so thank you so much for joining me in the session. Bye bye, take care, and uh, winding up the session in 1, exiting from the window from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, exit.